Good morning, class. So, in this video lesson, we are going to talk about the different properties of matter and kasama din dyan sa learning objective natin is the separation of mixtures. So, for the learning competencies that we are going to cover for this lesson, we are going to use the properties of matter to identify substances and to separate them. Pero, actually, ang gagawin natin medyo hindi tayo magfo-focus dito sa identify substances kasi medyo complicated na yung part na yan. Hindi talaga siya magja-jive dun sa lesson about properties of matter. We are going to focus more on separating them. Okay, separation of mixture and then i-connect natin siya sa properties of matter. So similarly, ito rin yon yung separate them, describe various simple separation techniques. So simple separation techniques such as distillation, chromatography, etc. Now, for the third learning competency, recognize the formulas of common chemical substances. We were already able to cover that in our pre-learning homework. So, all you have to do is memorize the common chemical substances na nasa bahay natin o kaya sa paligid natin. And then, memorize din yung chemical formula or chemical name nila. And then for the last learning competency, compare consumer products on the basis of their components for use, safety, quality, and cost. I-cover natin yan sa ating performance task which I will give you later this day. Okay, so those are our learning competencies. So magfo-focus tayo more on the properties of matter and the separation of mixture. Paano sila related sa isa't isa. So let's talk about separation techniques. The first one is chromatography. So what do you mean by chromatography? Chromatography is a laboratory technique for the separation of a mixture. The mixture is dissolved in a fluid. Yung fluid na yan, it can be a gas, solvent, water, or a hybrid between gas and a liquid called a critical fluid, which is called a mobile phase, which carries it through a system. Okay, pwedeng yung system na yon, pwedeng column, capillary tube, plate, or a sheet, pwedeng sheet of paper yan, on which is fixed a material called stationary phase. Now, para mas malinaw ito, kasi may mga terminologies tayo na ginagamit dito. We have a mobile phase and a stationary phase. O, panoorin natin itong video na ito.
In today's video, we're going to talk about paper chromatography. We'll take a look at how it's done, explain the theory behind it, like what the mobile and stationary phases mean, and also show you how to calculate RF values.
Hindi na natin i-cover yung RF
Now,
values.
chromatography is a general analytical technique used to separate the different substances in a mixture so that we can then identify them. And there are actually lots of different types of chromatography. But the one you need to know about is paper chromatography.
Paper chromatography is the simplest chromatographic technique. Actually, marami pa tayong na-move ko tuloy yung video natin, na-stop tuloy natin. Okay, marami tayong mga chromatographic techniques.
In today's video, we're going to talk
paper
about
chromatography, which is yung nasa video na to. We also have thin layer chromatography, column chromatography, liquid chromatography, and gas chromatography.
And also show you how to calculate RF values. A piece of filter paper, and use a pencil to draw a line near the bottom of the sheet, which we call our baseline. Next, you want to add your sample of ink, which you think might contain lots of different substances, to the pencil line. Then we need to find a beaker and fill it with a shallow amount of solvent, like water or ethanol. We are now ready to start, and we can place the filter paper into the solvent. But importantly, we have to make sure that we don't submerge our pencil line and our spot of ink, which is why we made our solvent shallow. And if you're being careful, you should really place a lid on top to stop the solvent from evaporating. Then we just wait for the solvent to seep up the paper, and as it does so, the different dyes that make up our ink will dissolve in the solvent and move up with it. What makes this interesting, though, is that each of the different dyes will travel up the paper at different rates, and so they'll end up separating out, which tells us that each one must be a different substance. So we've basically separated out the different substances. However, if any of our chemicals aren't soluble in that solvent, then they won't be able to dissolve and move up the paper, so they'll just stay on the baseline. Once the solvent has almost reached the top of the paper, we take it out and leave it to dry.
Okay, so that's chromatography. Okay, so the property of matter involved in the separation technique is solubility. So bakit solubility? Yung substance natin which is present dun sa sa ink, yung ink natin, it is made up of several substances. Okay? So ang nangyayari, okay, gamitin natin itong laser pointer. Ito yung ink natin, gawa siya sa iba't ibang substances. Kapag dinip natin itong filter paper natin dito sa sa solvent, ang nangyayari, yung solvent ay aakyat dun sa ma-absorb ng filter paper natin. At habang umaakyat yung solvent natin, ito yung solvent na parang basa, medyo dark ng konti na part ng papel. Habang unti-unting umaakyat yung solvent dun sa papel natin, pati yung mga substances na nandito sa ink na to ay madadala ng solvent natin. Madidissolve yung solvent na, yung substance na yun kasama ng solvent at aakyat dun sa papel habang umaakyat din yung solvent natin. So yung mas soluble na substance, okay, yun yung mas aakyat dun sa paper natin, sa filter paper natin na ginamit natin as chromatogram. Okay, ayusin mo natin. Ayan. So, bakit may mga substances na nandito sa baba, may nasa gitna at nasa taas. Yung mas mataas yung travel na substance, yan yung more soluble. This is more soluble dun sa solvent na ginamit natin. Samantalang ito, dahil konti lang yung travel niya, okay, this is less soluble. Hindi siya ganun ka lakas yung interaction sa solvent na ginamit natin. So this is less soluble. Okay. Ito naman ay dahil nasa gitna siya, average yung kanyang solubility. Average solubility. Okay? So, pag more soluble yung substance, mas malayo yung kanyang itatravel kasama ng solvent. Pero kung mas mahina yung solubility niya, mas konti lang yung pag-travel niya. Itong mga naiwan dito, yan yung mga insoluble yan. Insoluble dun sa solvent na ginamit natin dito. Ayan. Okay? Now, yung mobile phase, ito yon, yung ating solvent. Okay? While yung stationary phase, ito naman yung papel na ginamit natin. Okay? So, yan yung mobile phase and stationary phase. Now, this is a paper chromatography kasi papel yung ginamit natin. Now, meron pa kasi tayong iba't ibang mga types ng ng mga chromatography. Meron tayong column chromatography. Meron din tayong liquid chromatography. Naandyan din yung yung high performance liquid chromatography, or yung tinatawag nga namin na HPLC. Meron ding LC. Itong liquid chromatography, ang tawag namin dyan ay LC, liquid chromatography. Yung high performance liquid chromatography naman, mas advanced siya ng konti, HPLC siya. And then we also have the gas chromatography. So, marami siya. Meron pa pala. Itong paper chromatography ay pwede natin siya halos kapareho din siya nung tinatawag natin na thin layer chromatography. May similarity siya sa sa thin layer chromatography. Ang ginagamit nga lang dito ay ay glass sa thin layer chromatography. Chromatography. Ayan. Okay? So, kapag nag-extract ka ng gusto mong i-separate talaga yung isang substance mula sa isang mixture, halimbawa, yung mga chemicals na nasa katas ng halaman, ayan, pwede kang gumamit ng chromatography. O kaya mula mga substances mula sa isang mixture na nakuha mo sa environment, okay, o kaya sa animal na ginamit mo. O yun, pwedeng, para ma-isolate mo yung mga substances na yan, pwede kang gumamit ng mga advanced techniques na chromatography. Katulad ng mga na-mention ko dito, yung column, liquid chromatography, high performance, liquid chromatography, and gas chromatography. Itong paper chromatography, talagang pang lang siya, pang school setting. Kasi hindi mo talaga siya may separate na maigi yan. Nakita mo lang na nag-separate siya. Pero yung makuha mo talaga siya, ma-isolate mo talaga siya mismo. Hindi mo siya magagawa. Para ma-isolate mo siya at magamit mo yung na-isolate mo na material in an experiment, kailangan mo ng mga advanced techniques like itong LC, HPLC, at saka gas chromatography. Pwede rin yung yung column chromatography. Okay? So, next separation technique is distillation. Distillation is the process of separating components of a mixture based on different boiling points. So, this is a common setup uh, for for distillation. Okay? So, meron tayong, dito natin nilalagay yung ating mixture. For example, bumili tayo ng ethyl alcohol sa butika. Ang ethyl alcohol, okay? So, ethyl alcohol, normally, pag bumibili ka niyan sa butika, it's 70% ethyl alcohol. Ano ibig sabihin yan? Sa isang bote, meron kang isang bote na ganyan, no, na alcohol, that's 70% ethyl alcohol and 30% water. Okay? Yan yung bumubuo dito sa alcohol na binibili natin sa butika. Kaya siya 70% ethyl alcohol. Now, what if we want to get 100%, yung almost 100% na ethyl alcohol? Okay, halos purong ethyl alcohol gusto mo makuha. So, you have to distill it. So, ito yung pinakasimple na distillation setup. So, meron tayong distilling flask. Diyan natin nilalagay yung ating mixture. Hinihit natin yan hanggang sa umabot yung temperature ng vapor natin at saka ng liquid natin dun sa pinakamababang boiling point na meron tayo dun sa mixture natin. In this case, the boiling point of ethyl alcohol is 78.37 degrees Celsius. So, yun yung temperature dapat ng vapor natin at saka ng mixture. So, meron tayong thermometer para ma-monitor yung temperature ng vapor natin. Okay? Para ma-maintain natin yung init ng mixture natin, kailangan natin kontrolin yung init using the Bunsen burner. And then, habang nag-evaporate yung ethyl alcohol, ayan, dadaan na yung vapor natin sa condenser. Yung condenser ay dinadaluyan sa outer tube niya ng cool water para lumamig yung vapor na dumadaan dito sa inner tube natin. At, syempre, pag nalamigan yung vapor na yan, magko-condense yan. Kaya nga tawag natin dito sa device na to ay condenser. Okay? Para mag-condense yung vapor na dumadaan dyan. Okay? At pag nag-condense na yan, magdi-drip na yan dito sa ating receiving flask. Okay? Ang tawag natin dun sa na-distill natin ay distillate. Okay? Ito yung ginagamit natin na normal setup for a simple distillation. Pero paano kung yung mixture natin ay gawa sa maraming types ng substances? So kapag marami na yung mga substances sa paghiwa-hiwalay natin, we will have to use fractional distillation. Okay? Fractional distillation is used in oil refineries to separate a complex mixture into fractions that contain similar boiling points and therefore similar molecular weights and properties. So, panoorin natin yung example ng yung video na nagdi-discuss about fractional distillation.
In this video, you will learn how fractional distillation separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil. That is oil that has been taken directly out of the ground, either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are useful as fuels, and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form as crude oil, it can be a viscous, dark-coloured tar-like consistency, and the different fractions of hydrocarbons must be separated by fractional distillation for them to be useful. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of hydrocarbons with different chain lengths, some being short molecules and some being very long. Intermolecular forces act between molecules, and the longer the molecule, the greater the intermolecular force.
So this explains
As you can see here, the small molecules have weaker intermolecular forces, and so will require less energy to break them apart and turn them into a gas. They have a lower boiling point.
The
longer
liquids that we have to
molecules have
separate, the substances that we have to separate using fractional distillation. So kapag mas maliit yung mga molecules, mas mahina yung forces of attraction between them. So mas konti yung energy na kailangan nating i-apply, which means mas mababa yung temperature. Okay, pero pag mas mabibigat na o mas malaki na yung mga molecules na i-separate natin, then we'll be using higher temperature para ma-break yung bonds between molecules.
Greater intermolecular forces, more energy is required, a higher temperature will be needed to evaporate these molecules. They have a higher boiling point. Now we understand how chain length is related to the boiling point of a molecule. Let us look at how this method works. As you can see, crude oil is heated up to a high temperature outside of the fractionating column. The hot crude oil, now mostly in vapour form, is pumped into the column. The column has a heat gradient and is very hot at the bottom, going cooler as we move up to the top. Even at the very bottom of the column, where the temperature is still high, some long chain molecules with high boiling points begin to condense back into a liquid. These are collected at the bottom of the column. The rest of the molecules start to rise up the column, making their way through bubble caps in each tray. The bubble caps slow down the rate of the rising vapour, and eventually the vapours get too cool, condense, and are collected as liquids in the trays. Small molecules have low boiling points, and so condense much higher in the column, where the temperature is cooler still. As you can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. They are mixtures of hydrocarbons with similar boiling points. Each fraction has some important uses. Some examples of fractions are petrol, useful as a fuel for cars, naphtha, used in the manufacture of chemicals, kerosene as aircraft fuel, diesel oil, used as fuels for vans, cars and lorries, and bitumen, a mixture of large chain hydrocarbons used to lay roads. Now, at the end of this video, you should understand that crude oil is a mixture of important hydrocarbons, and that fractional distillation is...
Okay, so that's it for distillation. Now, for distillation, the property involved that we have to observe is the boiling point. Because we have to be familiar with the boiling point, especially in simple distillation, para ma-separate natin yung substance with a lower boiling point. Okay? But for fractional distillation, medyo hindi na natin masyadong kailangang i-concern yung sarili natin dun sa temperature, i-regulate yung temperature kasi yung fractionating column na mismo yung magsa-separate ng natin. Okay? Ng mixture natin. Okay, pero kung halimbawa, gusto mo isa-isa lang yung pagsa-separate, pwede rin naman. Okay? Halimbawa, doon ka muna sa mababang temperature, mababang boiling point, o doon ka muna mag-start. Tapos pataas na lang ng pataas. Hanggang sa, ayun, ma-separate mo na lahat ng components ng mixture. Depende sa strategy mo eh. Okay, sa fractional distillation. But still, you have to be familiar or be aware of the boiling points of the different substances in your mixture for distillation. Okay, next separation technique is evaporation. Okay? Ito, isa sa pinakasimple na separation technique. This technique is used to separate out homogeneous mixtures where there are one or more dissolved solids. Now, unlike in distillation, which is, ang involved ay mga liquids, okay, two or more liquids. Sa evaporation, meron ditong dissolved solid. Okay, halimbawa, yung salt nakahalo sa tubig. Okay? So, ang ginagawa natin sa evaporation, yung liquid, hinahayaan lang natin na completely mag-evaporate. Tapos, ang kukolektahin natin ay yung solid na may iwan dun sa container. Okay? So, this method drives off the liquid components. So, talagang hindi na natin ako evaporate o mag-vaporize ditulad sa asin. Ang asin ay non-volatile actually. Okay? So, ayan. So, pinapag-evaporate natin yung madaling mag-evaporate o volatile substance. Okay, so next separation technique is filtration. Filtration is a process used to separate solids from liquids or gases using a filter medium that allows the fluid to pass through but not the solid. So halimbawa niyan, let's say we have a suspension mixture of water, halimbawa water and yung suspended solids. Okay, pag suspended solid, hindi yan katulad ng salt and water na talagang nagmi-mix sila. So, sa suspended solids, nakahalo lang siya ng dun sa liquid natin, pero may tendency siya na mag-settle down. Medyo malalaki yung mga particles niya. Now, para ma-separate natin siya using filtration, we will be using a filter paper. Okay? May filter tayong gagamitin. And then, meron tayong funnel o yung embudo. Okay? Doon natin ilalagay yung filter paper. And then, we have a Erlenmeyer flask to collect the filtrate o yung liquid na tatagos doon sa filter paper natin. So, the solids that remain in the filter paper, we call that as the residue, while the liquid that passed through the filter paper is called the filtrate. So, ito yun, yung liquid na yan. We call that as the filtrate. So, kapag ikaw ay nagbubrew ng kape, ayan, yung coffee grounds na naiwan dun sa filter paper, yun yung residue. Tapos yung kape mismo na iniinom natin, yan na yung filtrate. Okay? O kaya kapag ikaw ay naggagata, kumukuha ng gata mula sa kinudkod na na nyog. O yun, yung nyog na naiwan dun sa tela o kaya dun sa sa salaan, yun yung residue. Tapos yung gata, yun naman yung filtrate. Yung filter natin dun sa sa gata, pwedeng yung salaan nga o kaya minsan tela. Kapag wala kang salaan. Minsan sa mga sa mga nagkakayod ng nyog, tela yung ginagamit nila eh. Okay? So that's filtration. So, for filtration, yung property of matter involved is particle size. So, yung mga malalaking particle size, hindi siya nakakatagos sa ating filter. Pero yung liquid na mas maliit yung particle size, nakakadaan siya sa filter natin. Kaya nakokolekta natin siya. So, ang next na separation technique na didiscuss natin ay the use of separatory funnel. So, a piece of laboratory glass, a separatory funnel is a piece of laboratory glassware used in liquid extractions to separate or partition the components of a mixture into two immiscible solvent phases of different densities. Now, take note of the word here, immiscible. Okay? Kasi baka hindi pa kayo ganun ka-familiar dyan sa term na yan. Actually, related din yan sa term na soluble or insoluble. Okay, just explain ko muna sa inyo. So, when we say soluble or insoluble, this is used when we are referring to the interaction or dissolution of a liquid to a solid or yung dissolution ng liquid with a gas and vice versa. Okay? So kapag interaction or formation ng solution between a liquid and a solid and a liquid and a gas, soluble or insoluble yung gagamitin natin na term. While for miscible naman, okay, miscible or immiscible, okay, we use this when we are forming a solution or a mixture between two liquids. Liquid and another liquid. Okay, example. Let's say for example we have salt or water, tapos hahaluan natin ng salt. Okay? So, liquid, tapos solid. Itong water and salt. So, magdi-dissolve ba yung dalawang yan? O magdi-dissolve ba yung salt sa water? Yes. So, therefore, this is soluble. Okay? Now, what if we have water and chalk? Maghahalo ba yung dalawang yan? So, yung chalk ay hindi yan maghahalo talaga. Sa simula mukha siyang naghalo pero after some time magsisettle kasi sa bottom ng container yung chalk. So therefore this is insoluble. Okay? So kapag liquid to solid ang nag-interact, then soluble or insoluble ang gagamitin natin na term. Now, what if yung liquid to gas? Example naman yan ay water and carbon dioxide in soft drinks. So, normally talaga yung mga gases, soluble naman sila sa liquids. Okay? Now, next, we have miscible. Paano naman yan yung miscible and immiscible? Liquid to liquid interaction yan. Like, for example, we have water and acetic acid. Acetic acid dito yung nagpapaasim sa suka. So, nagmi-mix ba yung dalawa? So, yes. Nagmi-mix yung dalawa. Kaya nga meron tayong suka, di ba? So, therefore, this is miscible. Okay? Pero kung meron kang water and oil, alam natin hindi nagmi-mix yung dalawa. So, therefore, water and oil ay immiscible. Okay? So, merong specific use yung mga terms na yan. Though, pareho lang sila ng konsepto kung naghahalo ba o hindi yung mga substances na yan. Pero, kapag liquid to liquid ang naghahalo, it's either miscible or immiscible sila. Pero kung liquid to solid or liquid to gas ang pinapaghalo natin, it's either soluble or insoluble sila. Now, for separatory funnel, okay, when we are using separatory funnel, ginagamit lang natin ang separatory funnel when we have two immiscible liquids or liquids that are not soluble or they do not mix with each other. Like for example, water and oil. Okay, so ginagamit natin ang separatory funnel kapag meron tayong mixture ng water at saka yung insoluble sa water, like for example, yung oil. Okay, now let's watch a sample video that will show us how to use a separatory funnel. Skip
Mixtures
na
are
natin.
not uniform in composition, like oil in water. Homogeneous and heterogeneous mixtures can be separated into their components using different techniques based on the type of mixture and difference in the chemical properties of the constituents of a mixture. Separating funnel is one of the techniques that is used for separating the components of a mixture between two immiscible liquid phases. One phase is the aqueous phase and the other phase is an organic solvent. This separation is based on the difference in the densities of the liquids. The liquid with more density forms the lower layer and the liquid with lesser density forms the upper layer. Materials required: beaker, filter funnel, separating funnel, mixture of oil and water, and stand with a clamp. Procedure: first, take the separating funnel and clamp it on the stand. Now, take a filter funnel and place it on the mouth of the separating funnel. Pour the mixture of oil and water into the separating funnel through the filter funnel. Then remove the filter funnel from the separating funnel and close the separating funnel using a lid. Now, take the separating funnel from the stand. Invert the funnel and shake it gently and slowly open the stopcock of the funnel to release the pressure inside the funnel. Again, place the separating funnel in the stand and allow the two liquids to separate completely. We can see that oil forms the top layer and water forms the bottom layer. Now, take a beaker and place it below the separating funnel. Remove the lid on the mouth of the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully into the beaker. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. Finally, label the two components transferred into the beaker as water and oil. From this experiment, we can infer that the immiscible liquids separate out in layers depending on their densities.
Okay, so that's how you separate oil and water using a separatory funnel. So what properties are involved in separating mixtures using separatory funnel? So as mentioned in the video, we have density and the miscibility of the liquids. So the denser substance will settle at the bottom of the separatory funnel, while the less dense substance will float on the surface of the denser substance. So magko-form sila ng dalawang layer. Since both substances are again immiscible. Kasi nga oil and water sila. Kaya magse-separate sila, tapos two layers ang ma-form dahil sa difference din ng kanilang density. Okay? By the way, separatory funnel is also used in extraction of substances. Let's say for example sa pag nag-extract ka ng katas mula sa halaman, minsan kasi you use non-polar substances. Like for example, yung hexane o kaya chloroform, hindi yun nadi-dissolve sa water. Pero normally kapag initially nagdudurog ka ng halaman o nag-extract ka ng halaman, may kasamang tubig yon. So, tapos hahaluan mo ng non-polar substance para ma-extract mo yung katas o yung mga chemicals na gusto mong makuha mula sa halaman. So, pag ganon na nag-extract ka ng katas mula sa halaman, normally talaga, gumagamit tayo ng separatory funnel. Especially, we have two different solvents in the mixture. Yung tubig na initially na nakukuha mo mula sa katas ng halaman, and then yung solvent na ginagamit mo to extract the substance from the plant extract. Okay, so next, we have sublimation. So sublimation is a method to separate a mixture of solids containing one which sublimes. Pag sinabi natin sublime, okay, this is a substance that immediately turns from, okay, so pag sinabi natin sublime, yung solid immediately turns into gas. Hindi na tayo dumadaan sa liquid phase. Okay? And one or more than one which does not by heating the mixture. But take note, hindi masyadong mataas yung heat na i-apply natin. Or else, kapag masyadong mataas yung heat na i-apply natin, yung solid, magli-liquefy pa yun. I-melt mo siya kasi sobrang taas ng ng temperature na in-apply mo. So, magdadaan pa siya sa liquid bago maging gas. Pero at normal temperature, yung solid diretso nang magiging gas yan kapag nagsasublime siya. Okay, example natin ng substance na nagsasublime ay ito, yung dry ice or solid na carbon dioxide. Okay? So, solid siya, pero at room temperature, it immediately turns to gas. Another example is naphthalene ball or mothball, yung bilog-bilog na kulay puti na ginagamit natin sa mga damitan para pantaboy ng ipis. So, yun ay nagsasublime din. Okay? Directly from solid, nagiging gas na. Okay? So, when do we usually use sublimation to separate components of a mixture? Halimbawa, kapag nagsiseparate tayo ng crushed na mothball or naphthalene ball na nakahalo sa asin. Halimbawa, intentionally pinaghalo natin yung mga yon. So, we use sublimation. I-expose lang natin siya sa normal temperature kung sana yung mag-vaporize yung naphthalene ball. Again, kapag ininit mo kasi, medyo mataas yung temperature, yung naphthalene ball ay pwedeng mag-melt. Okay, dadaan pa siya sa liquid. Pwede naman na hindi ka na gumamit ng init, medyo mabagal nga lang, pero directly from solid, magiging gas na kagad yung naphthalene ball. Okay, so sublimation, the property used to separate naphthalene ball from salt is yung property ng mothball na volatility. Very mataas ang volatile ang naphthalene ball compared sa salt which is considered as non-volatile o hindi agad nag-vaporize. Okay, next separation technique is magnetization. Ito madali rin lang to. A method that involves the separation of magnetic substances from non-magnetic substances by means of a magnet. Gumagamit lang tayo ng magnet. Kasi may mga substances, for example, mga iron filings, mga bakal, na pwedeng ma-attract sa magnetic field. Okay, so magnetic field o presence ng magnetic field yung property ng substance na meron tayo dun sa mixture. Like for example, yung sa iron filings, yun yung gagamitin natin to separate it from other substances na hindi magnetic. Okay? Another technique is adsorption. Ayan. So, adsorption is the process by which a solid holds molecules of a gas or liquid or solute as a thin film. Now, iba ang adsorption sa adsorption, ha? So, sa adsorption, ganito ang nangyayari. I-differentiate natin. Yung absorption, AB. Absorption. Iba yan sa adsorption natin na to. Okay? Sa absorption, let's say we have a foam. Ito ay foam. Tapos meron tayong pool ng maliit na puddle ng water. Mangyari, pag dinikit natin yung foam dun sa puddle ng water, yung water ay papasok mismo sa loob ng foam. Okay, sa loob mismo ng foam papasok yung water. That is absorption. But what about adsorption? Okay? Again, this is the process by which a solid holds molecules of a gas or liquid or solute as a thin film on the surface of the adsorbing material. Like for example, ang adsorbing material natin dyan ay we have activated charcoal. Okay, ang example natin yan ay activated charcoal. Halimbawa, ito. Let's say this is our activated charcoal. Activated charcoal. Ayan. So, yung activated charcoal o uling na may ginawa lang tayo dyan, normally ini-steam yan eh. Okay? Yung pinakamadaling paraan ng pag-activate ng charcoal ay pag-i-steam. So, medyo durog na charcoal tas ini-steam para medyo mawala yung mga oil niya sa mga pores niya. So, ang effect nun, mas lalong lalaki yung surface area niya kasi nagkakaroon pa ng additional space doon sa mga pores na inalisan ng oil. So, ang nangyayari during adsorption, let's say for example, no, we have a dye. Yung dye, hindi siya papasok sa loob ng activated charcoal. It will attach on the surface of the activated charcoal. So, yan. Dito lang siya, kakapit lang siya sa ibabaw o surface ng activated charcoal natin. Hindi siya papasok sa loob, katulad ng nangyayari sa absorption. Okay? So, ito yung reason din kung bakit nagagawa ng activated charcoal na mag-filter ng tubig o kaya magsala ng nakakalasong hangin. Ang activated charcoal kasi ginagamit yan sa sa mga gas mask. Okay? For example, no, nasa isang rally, tapos yung mga pulis o kaya yung mga pwede rin na yung mga aktivista ay naghagis ng tear gas. Ang tear gas kasi ay napaka-toxic na gas na may hirapan kang huminga at masakit sa dibdib. So, kapag nalanghap mo yon, talagang sasama ang pakiramdam mo. Pero kapag meron kang gas mask, yung nguso kasi ng gas mask ay nagko-contain yun ng activated charcoal. So, yung hangin na merong tear gas, papasok yun dun sa sa nguso ng gas mask na merong activated charcoal. Imbes na malanghap mo yung tear gas, ang mangyayari, yung tear gas na yun ay kakapit dun sa activated charcoal natin. Parang ganito. Okay? Diyan kakapit yung tear gas. Hindi mo siya malalanghap kasi kumapit na sa activated charcoal yung tear gas. That is adsorption. So, let's watch a video that shows how adsorption works. So, we have here 2 beakers with water at nilagyan nung student ng dye. Ang ginamit niyang color ng dye ay blue. Okay? Yung isa ay for reference, yung isa ay lalagyan niya ng activated charcoal para makita talaga natin na nagkaroon ng change sa color, na wala yung dye dun sa isang beaker. Ayan. So, lalagyan na ng activated charcoal. Now, yung activated charcoal nga lang na ginamit niya dito ay medyo malalaki yung particles kaya nagsettle kagad sa ilalim, sa bottom ng container. Pero minsan, katulad ng ginamit namin minsan sa experiment namin dati, talagang pino yung activated charcoal. Para yon, mas madaling mag-interact yung activated charcoal sa dye. Dito, katulad ng gagawin niya dito, matagal siyang magmi-mix. Kaya medyo ipa-fast forward natin yung video. Yan, matatagalan siya bago matapos mag-mix eh. Ayan. Medyo bluish pa rin ng konti kaya maghahalo pa rin siya. Di tulad kapag mas pino yung activated charcoal, mabilis lang 'yan. Mga ilang segundo lang pwede ka nang matapos. Ayan. So after haluin yung mixture ng tubig with dye at activated charcoal, halos nawala na yung dye. Ayan. So, nakita natin na nagbago talaga yung kulay ng mixture because the dye was adsorbed on the surface of the activated charcoal. Okay? Kaya minsan ginagamit din na first aid yung activated charcoal para sa mga nalalason. Okay, kasi yung lason kumakapit sa nag-a-adsorb sa activated charcoal. Okay, so that's adsorption. Ginagamit yan minsan talaga sa pagtanggal ng dye sa isang mixture. Okay. So, for adsorption, ang property na involved dyan ay adhesion. Adhesion is the ability of a substance to attach on the surface of another substance due to attractive forces. Okay? Ang attractive forces, i-discuss pa yan sa susunod. Particularly sa grade 12 pa. Okay. Now, last separation technique that I'm going to discuss is centrifugation. Okay, this is a technique used for the separation of particles from a solution according to their size, shape, density, viscosity of the medium, and rotor speed. So ito yung mga properties ng matter na involved sa separation technique. We have size, particle size, pwede rin yung shape, density, okay, and viscosity. Tapos yung, syempre, ito naman nga lang, nakabase ito sa speed ng pag-ikot uh, ng, ng centrifuge natin. Okay, the centrifugation is normally used when we have a mixture that is colloidal in nature. So, colloidal. Yung medyo maliliit yung mga particles na hindi natin siya kayang i-filter out. O pag gusto natin talaga magamit pa yung mga maliliit na particles na yun, so we have to separate it without using a filter. Okay? Gusto lang natin ma-isolate lang siya, pero gagamitin pa natin siya sa susunod. Okay? For example, yung components ng blood o dugo, okay? Kasi ang blood ay composed of several components. So, blood, binubuo yan ng several components. We have RBC or red blood cells. We also have WBC or white blood cells. Nandyan din ang plasma at yung platelets. Okay, sana wala akong na-miss out. So, yan yung bumubuo sa blood. So, para ma-separate natin yung mga components niyan, we use centrifugation. So, paano ba gamitin ang centrifuge to separate different components of a colloidal mixture? So, panoorin natin itong video na to.
Here is an example of the type of centrifuge you will be working with. As you can see, it is composed of a safety cover on the outside to prevent injury and spraying, a rotor which spins when the centrifuge is operating, and an on-off switch. Before operating the centrifuge, you must prepare your sample for centrifugation. First, always use a polypropylene centrifuge tube with a blue screw cap. Do not use a centrifuge tube with a white cap as they tend to break easily, and never use glass test tubes. Check the cap of your tube for cracks or protrusions. Caps that are concave are usable, while caps that are distended or splitting should not be used. When preparing your liquid sample, add up to 10 milliliters. When running a centrifuge, it is very important to balance the centrifuge by weight.
So, sa centrifuge kasi, kailangan mabalanse yung pagkakalagay natin. Pati yung timbang ay balanse sa magkabilang side para hindi masira yung centrifuge at hindi rin masyadong mag-vibrate yung ating centrifuge. Nangyayari yun kapag hindi balanse yung rotor o yung bagay na umiikot. Ayan, nagpa-vibrate. Ibig sabihin hindi balanse yung pagkakalagay natin ng sample. So, normally, para mangyari yon, ang ginagawa is kailangan pareho ng timbang yung magkabilang side. Pwede kang gumamit ng tubig. Yung isang container natin, vial natin, nagko-contain ng sample. Yung isa pwedeng tubig lang. Pero kailangan pareho sila ng timbang. So, katulad ng ginagawa nila dyan, ayan. Kailangan halos pareho sila ng timbang para hindi mag-vibrate masyado yung ating centrifuge.
Shut the safety cover and move the toggle switch into the on position. Consult your project guide for more information on how long your sample should stay in the centrifuge. Do not touch the centrifuge while the rotor is still spinning. Wait for the rotor to come to a full stop before opening the lid. Never stop the rotor manually, as this risks damaging the centrifuge and yourself. When the rotor has come to a full stop, remove your samples carefully. Take
So
care
now,
not to
after
shake or
mag-spin
pull
yan
the
ng,
tubes
ng ilang
quickly, as this
minuto,
will remix your separated
magsiseparate na
sample.
yung solid o yung
You will
heavier
likely see a
component
liquid layer
at yung
at the
lighter
top and
particle
a
yan,
pellet of solid
nag-separate na
material
sila.
at the
Pero
bottom.
mag-ingat,
Finally,
huwag
use a
isi-shake para
transfer
hindi
pipette to
mag-mix
remove
uli
the top
sila.
layer or supernatant from your centrifuge sample. Be sure to
Pwede
expel
mong
air from the
ibuhos,
pipette
pero
while it is
dahan-dahan lang.
outside
Pero
the
para
solution before
pinaka-safe, ayan,
remixing.
gagamit tayo ng ng
Then submerge the tape
micropipette.
down into the top layer and gently release pressure to draw the supernatant
Ingat din,
into
baka
the
mahigop
pipette.
nyo yung
Repeat this process,
yung solid
dispensing your
particles dun sa
supernatant
bottom
into
ng
a clean
container.
receiving vessel. Take care not to disturb the pellet at the
Ayan.
bottom. You may also centrifuge two immiscible liquids, such as oil and water. In this case, the hydrophobic layer may sit on top of your desired liquid. Simply
Kung
lower the tip
immiscible
of your
sila,
transfer
normally,
pipette into the
magsiseparate na
desired
agad
layer,
sila eh. So,
draw it into the pipette,
separatory
and
funnel lang
transfer it
ginagamit
into a
natin. Pero
receiving
kung,
vessel.
halimbawa,
You have now learned how to use a
ang
centrifuge to separate solid.
papaghiwalay natin ay components ng gatas. Isang liquid lang siya. Minsan may mga oils na na nagse-separate doon, tas yung tubig. So, yun, meron ka ring ma-separate doon na na dalawang liquids. Tas may mga solid particles din siya sa ilalim. Okay, pero kung dalawang immiscible liquids na siya, normally hindi na talaga maghahalo yun eh. Pwede mo nang i-separate yun using separatory funnel. So that's it for properties of matter and separating components of a mixture. So thank you sa panonood ng video. I hope you learned a lot from this lesson. Goodbye, class!